Alrighty. So now taking a look at example 3. On this one, we want to multiply and we want to write our answer in standard form. So we have 2x minus 1 to the power of 3. With a problem like this, we have to remember, what does an exponent of 3 mean? That means we're taking that quantity and multiplying it by itself 3 times. So if I were to expand this out of what that power of 3 is really saying, is it saying take 2x minus 1 times 2x minus 1 times 2x minus 1. Now, before we begin distributing and multiplying things out, we have to remember, you can only ever multiply 2 numbers at a time. Even if you're taking 5 times 2 times 3, you can only ever multiply 2 of those values at a time and then multiply it by the third. So I bring that up because we have to remember that I can't just start distributing 2x minus 1 into everything all at once. I can only multiply 2 quantities at a time. So I'm going to start with the first 2. So I'm going to take 2x times 2x to give me 4x squared. 2x times negative 1 is minus 2x. Then I take the negative 1 in the first quantity and distribute it into the second. And I get negative 2x plus 1. That third 2x minus 1 is going to carry down because I've not multiplied anything into it yet. I'm going to simplify some things in that first set of parentheses that I have here in pink, giving me 4x squared minus 4x plus 1. Now I'm going to take the last 2x minus 1, and now I can use that distributing process again and distribute these 2 quantities together. So I'm going to take 4x squared times 2x, which is 8x cubed. 4x squared times negative 1 is minus 4x squared. Negative 4x times 2x is negative 8x squared. Negative 4x times negative 1 is a positive 4x. And then that last term, plus 1 times 2x is 2x. Plus 1 times negative 1 is minus 1. So from here, I now need to combine my like terms in this last row. I have 8x cubed. Negative 4x squared minus 8x is minus 12x squared. 4x plus 2x is a positive 6x, and then minus 1 carries down. So multiplying everything, those 3 quantities throughout, I get 8x cubed minus 12x squared plus 6x minus 1. This was kind of a lengthy process though, right? Because we had to multiply the first 2 quantities, get that answer, then multiply that into the third quantity. And what if this problem had been 2x minus 1 to the power of 16? That would be an incredibly lengthy process. And while mathematicians recognize that there is a pattern happening whenever we have a binomial or 2 terms raised to an exponent. So this is where Pascal's triangle comes into play. So Pascal's triangle says that when you are expanding a binomial, and I'll move my floating head around a little bit. Here we go. So it says when you're expanding a binomial, the coefficients in front of each of those terms are the same as what Pascal's triangle says. And Pascal's triangle has 1 at the top of the triangle, then the next row is a 1 and a 1, and then it goes 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Hopefully you're beginning to notice some patterns here. And some of you might have learned about Pascal's triangle in past classes, but the really neat thing about Pascal's triangle is that there are so many patterns, and that Pascal's triangle actually ends up in natural environments like shells and things like that, in seeds. It's really incredible. So if you have time, I'd recommend Googling Pascal's triangle because you probably learn a lot of really neat information. But some things that you're going to want to know for the sake of this class. The way we get from one row to the next in Pascal's triangle is by adding the 2 numbers above it. So for example, 1 plus 1 is 2, so that's why this number here is 2. If we were to continue that process, 1 plus 2 is 3, 2 plus 1 is 3. You might be wondering, well, how are we getting these ones on the sides, though? You could think of it as there's like zeros out here, but we don't write them, and so 0 plus 1 is always 1. Or you could just know or remember that Pascal's triangle is always surrounded by ones on the outskirts of the triangle or on the outskirts of the pyramid. Now let's talk about how we identify which row is which. Row 0 is this top row. So this is row 0. Row 1 is the second one. Row 2 is after that. And then row 3. And then row 4. And then row 5 is the one that we have on bottom here. Have you figured out how we're numbering these rows? The way we identify the numbers of our rows is looking at that diagonal of the second number in on either side of the triangle. The second number in is a 1 for row 1. The second number in underneath that is a 2 for row 2. Second number in is a 3 for row 3, then 4, 5, and we could continue that. If we wanted to figure out what row 6 was, we're going to start with the 1. We know a 6 is going to come after that, and it's symmetrical, right? So however it begins is also how it's going to end. If I take 5 and 10 and I add those together, I get 15, which is my next number. 10 and 10 is 20, which is the next. 10 and 5 is 15, and then comes 6 and then 1. And if we wanted to do row 7, we can continue this. And Pascal's triangle actually goes on infinitely. How this relates to how we can expand binomials is these numbers of Pascal's triangle are your coefficients of this pattern that we're about to apply. How that then relates to expanding these as well is if you have something like a plus b, those exponents of a and b are going to go in ascending and descending order. So this table of Pascal's triangle being applied is a little bit confusing, so I don't want to go too much more in depth on this table other than showing you Pascal's triangle and giving you a brief overview of this binomial expansion. It should make a lot more sense once we go through an example problem. So, using Pascal's triangle to expand binomials, there's a 5-step process that you can use if you would like. Or not a 5-step process, I'm sorry. There are 5 things to consider when expanding binomials. So for a binomial expansion of the form of a plus b to the power of n, the following statements are true. You're always going to have n plus 1 terms. So for example, if that exponent is a 5, your final answer should have 6 terms or 6 pieces added or subtracted together. The coefficients are the numbers from the nth row of Pascal's triangle. The exponent of a is n in the first and decreases by 1. The exponent of b is 0 in the first term and increases by 1. And the sum of the exponents in any term is n. So the ones we're really going to focus most of our attention on when expanding these are parts 3 and 4. And I'll explain what those mean when we go through example 4.